Woohoo! We are live. This is Math 60 Intermediate Algebra, and we are in section 3.6, and we are working with word problems. Woohoo! And we're going to solve these using systems of equations. So since it's going to be word problems, I have my colors with me. I have my supportive friend right there, and I have a calculator because real world problems tend to not turn out as nicely. Sometimes they do, sometimes they don't. So what we're going to do is we're going to go into number 2. Now, if you were with us, if you watched the video for number 1, you'll recognize that number 2 is very, very similar. And one of the goals of 3.6 is to help you see how different word problems are all connected so that it's easier for you to approach them if you all know what's coming. For example, if I read this, I want to, and try not to let your eyes glaze over, I know it's easy to. I want to obtain 160 centiliters of a 70% alcohol solution by mixing, right there, that's the important word, it's going to be a mixture problem. So if you see a mixture problem, you will know, okay, this is how I'm going to approach it. This is the chart I'm going to use. So let's get started. Let's talk about some of the wording. Speaking of 160 centiliters, it's a goofy word if you're not used to the metric system, or if you're not used to art. I feel like I would be terrible at Pictionary. Okay, so this is a 2-liter soda bottle. And hopefully everyone is fairly familiar with that. It's on the screen. It's about like that big. The screen's not quite big enough for a 2-liter soda bottle, but it's about that big for where I am. And then if you imagine half of that, that would be 1 liter. And then if you imagine taking a little tiny piece of that, a centiliter is 1/100th of a liter. So a centiliter, and I drew it pretty big just so you could see it. But if you imagine cutting that into 100 pieces, so it's a very small amount. Now, who's going to use centiliters? Well, if you go into science, especially chemistry, or if you go into medicine, you're going to have all sorts of it. Plus, as you get older, if you find that you get a lot of, you start to treat various illnesses, you start to take medicines, you're going to become more familiar. If you have cats and you've been giving subcutaneous fluids, you know all about milliliters and centiliters. So there are lots of times it'll come up in a quote unquote real life. So we've got 160 centiliters of a 70% alcohol solution. And I'm starting the paragraph with that, but it turns out it says, I want to obtain. Obtain means to get. I want to get or to have this. So this is the answer. This is the result. And what am I mixing? I'm going to mix distilled water with an 80% alcohol solution. So let's talk about those two. So I'm going to draw some beakers, more or less. And for the distilled water, I'm just going to use blue. Now, what is distilled water? A lot of people want to know. Well, it's what happens when, just a second. It's hard to talk and write at the same time. Distilled water is what happens when you put a bunch of water over heat. And then the heat makes the water boil, and then you get steam and water vapor that comes up. And what happens is the steam and water vapor comes up and you grab it and you collect it and you recondense it. Now, what is the purpose of this? Well, when you heat up the water and you get the steam, all the stuff, the crud that's in the water, whatever might be in the water. So it could be different kinds of salts. It could be just regular old dirt. It could be metals. I hope not, but you know, Michigan, yeah, sometimes it happens. So all that stuff gets left at the bottom of the water, and the steam that goes up that we collect that becomes distilled water, that is more pure. And so when we talk about distilled water, we think of it as pure water. There's nothing in it, certainly no alcohol. Next up, I'm going to add another beaker. Ooh, these are lovely. Now this beaker is the 80% alcohol solution. And I don't have a good color for it, so I'm just going to make my alcohol solution orange. There's alcohol. Now, what does it mean to be in solution? Well, it means that somebody has mixed you with some other stuff. There we go. In this case, in our problems, we're going to assume that the alcohol, here's the 80% alcohol, is mixed with water. So that would be 20% water. And I'm going to use H2O for short. H2O, 2 hydrogens to 1 oxygen smashed together. It looks a little like Mickey Mouse. And you get H2O, which is how you make water chemically. 20% water, 80% alcohol. And again, we're assuming these are pure. So when I say alcohol solution, that's all that's in there. Fun fact, cool word, if the solution is a solution with water, which we assume it is, it's an aqueous solution, which is a cool word. Okay, so we're going to mix these two, and we're going to end up with a bigger beaker because we've mixed them. None of this is to scale. This is just to try to give a picture of what's happening. And then we're going to try to obtain a 70% alcohol solution. And what does that mean? Well, that means that this one has more water than this one did as a percentage. This one only has 70% alcohol. And then that leaves how much for water? You're right, 30%. So the first question is this even possible? Does this even make sense logically? If I take a bunch of water and I mix it with an 80% solution, can I get more water, less alcohol? And the answer is yeah. If you add water to this, then it thins out the alcohol solution. Another way to look at this is if I look at, so distilled water is 0% alcohol. So if I go from 0% and I add it with 80%. Now, when you add percentages like this, you're not really adding percentages. What you're actually doing is you're looking at a more of an average. And if you want to know more about that, come talk to me individually because that's a whole conversation all by itself. But you're not really adding. We can't just do 0 plus 80. We can't do that equals 70. It wouldn't make any sense. But I can look at where the relative percentages lie. Between 0 and 80%, if I did half and half, I would expect to be right in the middle at 40%. That's the middle point, right? Halfway between 0 and 80 is 40. Now we want to end up with 70. So that would be about here. That's where we want to be. That's our goal. It's a lot closer to 80%. So I'm going to expect that I'm going to add a lot of the 80% and just a little bit of the water to thin it out. We'll see. The problem with these chemistry mixture problems is until you've done a few of them, you can't really guess what the answer will be, and you will be surprised by the answer. I'm usually surprised by the answer, and I've been working with these for 25 years. Woohoo! I started when I was 3, you understand. Okay, so let's see. I don't feel like I have enough space for my chart, so I'm going to go ahead and give myself another piece of paper for my chart. So this is 2 continued. I'm going to set up a chart. Now, if you're looking at your notes from number 1, you're going to notice that this is very similar and that I still have not learned to use a ruler. Spoilers, I don't think I'll ever learn how to use a ruler, to be honest. Okay, so let's look at what this thing looks like. So this is a mixture chart, very similar to the previous one. The big difference is I do not have a formula here, but I will show you what to do. Coming down here, I'm going to be adding in the first column, I'm going to be adding the distilled water and the 80% solution, and I'm going to end up with the 70% solution. So these are the two things I'm going to mix, and this is the result. You could also call this the mix. You can call it whatever you like. This chart is for you to help you organize your thoughts. If you do not need this chart, skip it. Okay, so since I didn't have a formula, I'm going to tell you how to approach this one. I'm going to start with total amount. So the total amount of these is actually not given. If we look back at the problem, the only quantity, and so this will be in volume. So like in this case, this will be in liters. The only thing I've got is 160 centiliters. So it's not even in liters. It's in, ooh, I don't like that. It got too squashy. What? I didn't do anything. I'll write it down here too. This is going to be in centiliters. So, and when I look at this 160 centiliters, this is the 160 centiliters is the total amount. It's the mixture amount. And it's a small c and a capital L. So I'm not told the amounts of distilled water or the 80% alcohol solution, so I need two variables. And here I'm going to guess that a lot of people are going to be really happy with our old friends X and Y. So far, so good? Okay. Now, before, you might recall that in the previous investment problem, if you watched the first video, this was the percent, the interest rate. It's a percent that's an interest rate. We have percents here, but these are strength. So the strength is going to be measured in a percent or a decimal. So distilled water is 0% alcohol. And that is 0.00 as a decimal. The second one down is 80% alcohol, which is 0.80. Now, I told you that we didn't need to do this in the investment, but for this one, we actually do know what the strength of the final mixture is. So I'm going to go ahead and use that. 70% alcohol equals 0.70. Now, one question you could ask me is, could I keep track of the water instead of the alcohol? And you totally could, but it would flip everything upside down. So this would be 100% water, this would be 20% water, and this would be 30% water. But if you wanted to, you could go that way too. So it's kind of like the negative space created by this problem. Okay, so as we go along, you'll recall with the investment, I took the principal times the interest rate times time, which we don't have time here, thankfully. And then we just multiplied them together. Well, let's look. If I have 160 centiliters and I multiply times 70% alcohol, what do I get? What is the quantity I'm measuring? Well, if I multiply the whole quantity times 70%, I just get how much alcohol. So I'm going to write here amount of alcohol. Now, if instead of an alcohol solution, if this were a jelly bean solution, and I don't know, I'm making things up, then this would be the amount of jelly beans, right? So it's whatever the strength counts. If you're looking at the strength in terms of the percentage of water, then what you would do is you do amount of water here. So it depends on the problem. Okay, so I'm going to go ahead and I'm going to say, remember, we usually set these charts up with multiplication in mind. And in this case, yes, We multiply the total amount times the strength, and we get the amount of alcohol. And this will also be in centiliters. So I do X times 0 equals, surprise result, 0. There's no alcohol in this one, so there's no alcohol. Okay, Y times 0.80 is 0.8Y. I'm simplifying. And generally, the convention is we write numbers in front of letters. The coefficient goes in front usually. You don't have to, but it is convention. Those of you going on to like calculus, you want to start paying much more attention to how you write things, because that's going to become more and more important as you move on up through math. Okay, and then this one, I take the 160 times 0.70, and I can actually calculate this. This is something that I know the values for. 160 times 0.7 equals 112. So in other words, out of this 160 centiliters of just the mixture, and it wouldn't look like this, it would be all mixed together. Of this, 112 centiliters would be the alcohol. And then we could do a quick calculation. 48 centiliters would be the water. So you can actually count out how much is alcohol and how much is water. And right now, what we could do is we could take a break here and say, what the heck would you even do this for? And the answer is that there are very strict laws when, if you were someone who was producing, say, bourbon or even beer or wine, there are very strict laws about how much alcohol can be included in your drink. So, and I don't, off the top of my head, I don't know the percentages, but if you give someone a drink that has too much alcohol in it as a percentage, like if you drank 100% alcohol, it really is bad for you. It's a poison. So there are rules for each different type of drink. If you're selling a wine or a beer or hard alcohol, different states have different rules. But the problem is that when you actually create the alcohol, you actually put it in to ferment, you let the little yeasties eat the sugar and create alcohol, they don't know the laws. And so sometimes you end up with more or less of the alcohol than what you were aiming for. So this is the kind of calculation that if you were a brewmaster somewhere, if you were the, I can't think of the word for what you call it when someone is the wine person. I can't think of that word. And this is just falling down. And I'm just moving it back up. What? Sorry about that. That just fell down. That was exciting. Ooh, and it won't stay up. Oh, I'm having a moment. Let's see if that will keep it up at least for now. Okay, so that's what you would do this for. We are in the home stretch. This is very exciting. Now, if we take a look at our chart, again, with mixture, because we're mixing, we're going to be able to add down. So I'm going to look at this first column, just like we did in the previous problem. And I'm going to say, oh, well, the amount of distilled water plus the amount of the 80% has to equal the total volume. And oops, I guess I could put green there too. The amount of alcohol also needs to be able to add down. So let's see, 0 plus 0.8y equals 112. And that comes from the last column. As before, the strength, the percentages are really squirrely. You cannot add them most of the time. There are certain times when you can, but most of the time you cannot add percentages. So there's nothing we can do with this. This column just helps us get from here to there. That's what it's useful for. Okay, so I've got two equations. I'm going to write them down again here, make it easier to look at. X plus y equals 160. and 0.8y equals 112. Well, I don't really have a situation where elimination is necessary. I can take this equation right here and say, because there's no x, I just solve for y by dividing both sides by 0.8. 112 divided by 0.8 is 140. Okay, so y equals 140. So then if x plus y equals 160, x plus 140 equals 160. Subtract 140 from both sides, and x equals 20. Woohoo! So x equals 20 centiliters. Y equals 140 centiliters. Woo! Now, can we check? Well, just like with the previous problem, it is really hard for students to check because it is hard to put these numbers back into the original problem, especially if you're struggling to create equations. We could double check the equations, which if you look down here, you're going to say, okay, yeah, that worked. You could look at this little thing that I wrote right there where I said between 0% and 80%, 70% is way closer to 80%. So we expect more of the 80%, the y. And the answer is yeah, we used a lot of the y and just a smidge of the water. So we just added a little bit of water just to fluff up the water content in this, to drive down the percentage of alcohol down to 70. In my class, if you set up the chart, you can give the answer that simply. If you do not set up the chart, you need to tell me 20 centiliters of distilled water, 140 centiliters of the 80% solution, if that makes sense. But if you've got the chart here, I can read it off the chart, and I'm happy with that. Okay? Woohoo, you guys are awesome. We made it through. Yay! 15th time is the charm. Yay! Okay, next up, more word problems. Woohoo! Math on, guys.